When the power grid fails and modern heating systems shut down, most families face a life-threatening emergency. But in Amish communities across the northern United States, winter storms that paralyze entire cities barely register as inconveniences. Wood heat. The foundation of Amish winter survival begins with understanding wood as more than just fuel. It's a complex system of energy storage that requires year-round planning and precise execution. Experienced Amish men can identify the best heating woods by examining bark patterns, wood density, and moisture content in ways that would impress professional foresters. Oak, hickory, and maple provide the longest, hottest burns for overnight heating. Softer woods like pine and poplar work perfectly for quick morning fires when rapid heat is needed. The secret lies in mixing different wood types throughout the day, creating heat profiles that match family activities and weather conditions. A typical Amish household burns between 8 and 12 cords of wood each winter, with each cord representing hundreds of hours of cutting, splitting, and stacking labor completed during warmer months. Food preservation. Winter nutrition in Amish communities relies on preservation methods that maintain fresh food quality for months without refrigeration. Root cellars dug into hillsides maintain consistent temperatures between 32 and 40 degrees Fahrenheit, creating natural refrigeration that keeps potatoes, carrots, apples, and cabbage fresh through the coldest months. The science behind these underground storage systems involves understanding thermal mass and insulation principles that modern refrigeration technology tries to replicate. Earth provides consistent temperature regulation, while proper ventilation prevents moisture buildup that causes spoilage. Strategic shelving systems organize different vegetables according to their storage requirements, with some items needing higher humidity while others require drier conditions. Meat preservation combines smoking, salting, and cold storage techniques that create protein sources lasting entire winters. Hams cured in autumn provide steady nutrition through spring, while properly smoked sausages can remain safe and flavorful for over 6 months. These preservation methods require precise timing, specific salt concentrations, and temperature control that demands deep understanding of food science principles. Water systems. Maintaining water access during freezing temperatures requires engineering knowledge that rivals modern plumbing systems. Hand-pumped wells use mechanical advantage principles to draw water from depths where ground temperatures remain above freezing. These pumps function through lever systems that multiply human force, allowing individuals to access groundwater even when surface temperatures drop below zero. Strategic well placement takes advantage of geothermal principles where earth temperature remains constant below the frost line. Proper well construction involves casing systems that prevent contamination while allowing access during extreme weather conditions. Maintenance requires regular checking of pump mechanisms, lubricating moving parts with natural oils, and ensuring proper drainage to prevent ice formation in critical components. Indoor water distribution relies on gravity-fed systems that eliminate dependence on electric pumps. Elevated storage tanks filled during warmer periods provide water pressure for household needs. Strategic pipe routing through heated areas prevents freezing, while proper insulation using natural materials like straw and animal hair maintains flow during cold snaps. The community approach to water management includes shared wells serving multiple families, reducing individual maintenance burdens while ensuring backup access if primary systems fail. Ice harvesting from frozen ponds provides additional water sources and creates opportunities for cooling food storage during warmer months. Lighting solutions. Illuminating homes without electricity requires fuel management and safety protocols that prevent fires while providing adequate visibility for daily activities. Kerosene lamp systems involve understanding different fuel grades, wick materials, and chimney designs that maximize light output while minimizing fuel consumption and safety hazards. Traditional lamp maintenance includes trimming wicks to proper lengths, cleaning chimneys to prevent soot buildup, and adjusting flame height for optimal brightness without producing smoke. Different lamp designs serve specific purposes, with table lamps providing focused light for reading and work, while wall-mounted fixtures offer general room illumination. Fuel production often involves community cooperation, where families share costs and labor for purchasing and storing lamp oil. Strategic fuel storage requires proper containers, ventilation systems, and fire safety measures that prevent accidents while ensuring adequate supplies through winter months. Candle making from animal fats provides backup lighting and utilizes waste products from meat processing. Tallow candles burn slowly and produce steady light, while proper wick preparation ensures even burning without excessive dripping. The process involves rendering animal fats, preparing wicks from cotton or flax fibers, and molding techniques that create uniform, long-burning candles. Clothing strategies. Surviving brutal winters requires layering systems that trap body heat while allowing moisture management and freedom of movement. Traditional Amish winter clothing involves multiple garment layers designed according to principles that modern outdoor gear manufacturers study and attempt to replicate using synthetic materials. Base layers use wool or linen fabrics that wick moisture away from skin while providing insulation even when damp. Middle layers include quilted vests and sweaters that trap warm air in multiple small pockets. Outer garments feature wind and water-resistant materials that protect underlying layers from weather exposure. Footwear systems involve multiple sock layers, felt boot liners, and leather outer boots treated with natural waterproofing compounds. Hand protection includes liner gloves underneath work mittens designed for specific tasks. Head covering involves multiple hat layers that can be adjusted according to activity levels and weather conditions. Community clothing production involves shared labor, where families specialize in different garment types. Quilting bees create bedding and clothing with insulation properties that rival modern synthetic fills. Sheep shearing, wool processing, spinning, and knitting require coordinated seasonal activities that produce clothing materials throughout the year. Clothing repair and maintenance skills ensure that garments last for decades with proper care. Darning techniques repair worn areas, while patching methods extend garment life. Strategic clothing exchanges allow families to share items as children grow and needs change. Insulation methods. Creating thermal barriers in homes without modern insulation materials requires understanding heat transfer principles and utilizing available natural resources. Traditional chinking involves mixing mud, straw, and animal hair to fill gaps between logs and construction. This mixture dries to create effective barriers against air infiltration while allowing some moisture transfer that prevents wood rot. Banking houses with earth, snow, and organic materials creates additional thermal mass around foundations. Strategic placement of these materials provides wind protection while adding insulation value that reduces heat loss through basement walls and floors. Snow banking requires understanding snow density and settling patterns to maintain effectiveness through winter. Interior insulation involves hanging quilts and blankets over windows and doors during extreme cold periods. These temporary measures add insulation layers while maintaining access to natural light and ventilation when weather permits. Strategic furniture placement creates dead air spaces that provide additional thermal barriers. Attic insulation uses straw, corn husks, leaves, and other organic materials that trap air while allowing moisture transfer. Proper installation prevents settling while maintaining insulation effectiveness. Ventilation systems prevent moisture buildup that could compromise insulation performance or create ice dam problems. Community support. Winter survival depends on cooperation systems that ensure no family faces emergencies alone. Coordinated woodcutting involves multiple families working together to harvest, process, and distribute firewood according to each household's needs and labor contributions. Shared tools and equipment reduce individual investment requirements while ensuring access to necessary resources. Emergency assistance protocols activate when families face equipment failures, medical emergencies, or resource shortages. Community networks provide immediate help with fuel, food, shelter, repair, and medical care. Rotating responsibility systems ensure that assistance burdens are distributed fairly among families. Shared labor projects include building maintenance, food preservation activities, and preparation work that benefits entire communities. Barn raisings provide additional storage and workspace for winter supplies. Group activities like butchering, preservation, and equipment maintenance create efficiency while strengthening social bonds. Communication systems during storms involve designated messengers, signal fires, and check-in protocols that ensure family welfare during isolation periods. Emergency shelters in central locations provide refuge if individual homes become uninhabitable. Ice harvesting, creating year-round cooling and food preservation, requires ice harvesting operations that capture winter cold for summer use. Ice cutting involves identifying optimal ice thickness, cutting techniques, and handling methods that maximize yield while ensuring worker safety. Proper ice requires clear, dense formation at least 12 inches thick for safe harvesting. Storage techniques involve underground ice houses with drainage systems, insulation barriers, and packing methods that minimize melting. Sawdust insulation provides effective thermal barriers that preserve ice for 6 to 8 months. Strategic icehouse construction utilizes natural cooling principles and drainage systems that prevent water accumulation. Community ice cutting events involve coordinated labor where families work together to harvest, transport, and store ice for multiple households. Specialized tools include ice saws, tongs, and slides that facilitate efficient harvesting operations. Safety protocols prevent accidents during dangerous work on frozen surfaces. Ice distribution systems provide cooling for food preservation, medical care, and comfort during summer heat. Proper ice management involves rotation systems that use oldest ice first while maintaining quality standards. Understanding ice preservation principles allows families to maintain cooling capacity throughout warm weather periods. Storm preparation. Surviving severe weather requires prediction methods and preparation routines that ensure family safety during extended isolation. Traditional weather forecasting involves observing animal behavior, wind patterns, cloud formations, and atmospheric pressure indicators that provide advance warning of approaching storms. Stockpiling essential supplies includes fuel reserves, emergency food supplies, medical preparations, and equipment maintenance that allows families to remain self-sufficient for weeks. Water storage systems provide backup supplies if primary sources freeze or become inaccessible. Fuel reserves include extra firewood, lamp oil, and candle supplies calculated for extended cold periods. Animal care preparations involve shelter reinforcement, feed stockpiling, and water system protection that ensures livestock survival. Emergency procedures include bringing animals into heated spaces if necessary. Food production continues through winter using techniques like sprouting and indoor growing that provide fresh nutrition. Communication preparations include establishing contact schedules with neighbors, preparing emergency signals, and organizing check-in systems that ensure family welfare during isolation. Emergency supply caches located in outbuildings provide backup resources if main houses become inaccessible. Heat conservation. Maximizing available thermal energy requires daily routines and spatial management that minimize heat loss while optimizing comfort. Room closure systems involve sealing off unused spaces during coldest periods, concentrating heating efforts in essential areas. Strategic door and window coverings provide additional insulation layers that reduce heat transfer. Body heat management includes shared sleeping arrangements, group activities in heated spaces, and clothing strategies that maximize personal warmth. Hot water bottles, heated stones, and other thermal mass objects provide personal heating that extends fuel efficiency. Cooking methods utilize residual heat from stoves for warming spaces after meal preparation. Strategic meal planning coordinates cooking activities with heating needs to maximize fuel efficiency. Food preparation techniques include using retained heat in ovens for baking and warming. Daily activity scheduling concentrates physical work during coldest periods to generate body heat naturally. Strategic work planning coordinates outdoor activities during warmest parts of days. Indoor work arrangements utilize available light and heat most effectively.